Hello everyone, welcome to the channel Understanding.Concepts.Of.Physics, and here we have yet another numerical, another very short numerical. Probably this would be also a very small video, so let's see how much we are able to do today. Now you can pause the video and go through the question. I'll just mark the given conditions, what things are given. Length is given as 100 centimeters, note that it's centimeters. Then restoring force is something I need to get. Okay, then mass is given as 50 grams, again this is in CJ system, and displacement is given as 3 centimeters from the mean position. So they are saying that if there is a simple pendulum and its length is 100 centimeters, and if it is oscillating like this, so when it is at a distance of 3 centimeters from the mean position, and the mass is 50 grams, then what is the restoring force acting on this at 3 centimeters? So this is what the question is. So let's see. I'll just jot down the given conditions in a tabular form. So length is given as 100 centimeters. I'll convert this into meters, 1 meter. Mass is given as in 50 grams. Now grams to kg will take you 10 raised to minus 3. So whenever you want to convert from grams to kg, 10 raised to minus 3. And displacement is given as 3 centimeters, so centimeters to meter. I have made an error over here, it should be a meter over here. So it's a meter. Okay. It's a meter over here. Okay, so now centimeters to meters is 10 raised to minus 2. So I've just converted that into everything in SI system. Now somebody might argue that why if everything is in CJ system, why we need to convert that into an SI system? Now not a problem, but to the weaker students, you should be knowing that G ka value, when we are going to substitute the value of G in the formula, I'll come to that point how to get that formula. G ka value is mostly known as 9.8 meter per second square. Now in case if you are putting that in CGS, make sure that you put G ka value as 980 centimeters per second square. Now many people might miss out on this part and they will really struggle with the problem. But if you are familiar with working in CGS, then keep this in the same system and put G ka value as 980 centimeters per second square. Else, if you are if you are in doubt, then convert everything into SI system and then put the value of G as 9.8. So by mistakenly also you will be saved from this, because 980 is not the number which is used very regularly. So restoring force is something we are supposed to get. So now you'll say, okay, where is this formula coming from? So if you remember, when we had done the simple pendulum ka article, let me check if I have it. Yes, so here we have, so simple pendulum, motion of a simple pendulum as a linear simple harmonic motion. So this was the rigid support, this was the semi-vertical angle, length of pendulum is equal to length of string plus the radius of the bob, and this is that pendulum, and this is that restoring force mg sin theta. So restoring force is mg sin theta. Now how does that come? If you see the red lines on this entire diagram, you will see that gravitational force mg is acting downwards and the tension is acting upwards along the string. Now this gravity can be resolved into two components, that is mg sin theta and mg cos theta. Adjacent side, if you wish to find out the adjacent side, it is always mg, that is the hypotenuse, times cos theta. So this is mg cos theta, and mg sin theta is the opposite side, which I am not drawing it over here, I am just drawing it over here. So that is mg sin theta. So mg sin theta is the restoring force, and mg cos theta is actually balancing the tension. So from this formula mg sin theta, I am just going back to my numerical. So this is that part. So Fr is the restoring force, which is equal to mg sin theta. Now if theta is small, I can write as sin theta is approximately equal to theta. So I have just replaced that theta, and I have also ignored the minus sign as of right now. We know that negative sign just indicates that the restoring force and the theta is always in the opposite direction. Then you have this theta is equal to arc upon radius, which is the formula which we have been using in while deriving that part as well as this is the formula from math as well. So theta is equal to arc upon radius. If this formula, if you recognize, then theta, this is the theta, which is equal to arc is x, and upon radius is L, so this is that radius. So theta is equal to arc upon radius, this is the formula. So we can just write theta is equal to x upon capital L. So going back to the problem, theta is equal to x upon L, so mgx upon L. Now it's a time to check if we have one equation and one unknown, because if we have one equation and one unknown, things will be sorted. So Fr is something I need to find out. L is given to us, M is given to us, G is given to us, and X is also given to us. So I have one equation and one unknown, my problem will be solved. So I'll put the mass value of mass as 50 into 10 raised to minus 3, G as 9.8, and displacement as 3 into 10 raised to minus 2, and length is given as 1 meter. So I put all the values. Then this 10 raised to minus 3 and this 10 raised to minus 2 will become 10 raised to minus 5. You just have to add them up, and then 50 threes is 150, so this is 150. Then you have to multiply this, but I would always hesitate. I would always remove this point. So if I remove this point on the right, this point which is on the right will go to the left. So one point going right, 1 point going left. So that we can do, and that is 15 into 98, 10 raised to minus 5 as it is. And if you read the table of 15, you get 1470 into 10 raised to minus 5. And just to put it properly, it's 1.47. I mean, I'm just shifting this 3 digits over here. The point is when there is no point in the number, there is a point at the end. So the point shifts 1, 2, 3, and this 10 raised to minus 5 will reduce to minus 2. Because there is 3 shift, we will reduce this by 3. So 1.47 into 10 raised to minus 2 Newton, because it's a force, that's why the unit is Newton. So this is the problem which we are about to we actually solved, and the answer is actually matching with the given answer as well. Thank you so much for watching. Have a nice day, and subscribe the channel, like the channel, and like the video, and as well as share it with your friends and families who are into grade 11, grade 12, or any boards which they might be in, and make the most out of it. Thank you so much. Have a nice day. Bye.